what's Oracle up to with WebRTC? So, certainly many of you know Oracle from the work we do in databases. That's not my part of Oracle. Oracle actually has a communications business unit that builds infrastructure solutions to sell to the Verizons, the AT&Ts, the Fortune 500s of the world. So that's really what we're involved in. And I had the chance to work with Chad as young engineers going back 10 years, and primarily working on voice in an RTC context. And Oracle's strategy is really to focus on the shift in communications from what we call the switch, or PBXs and big contact center infrastructure solutions, to more web and mobile applications. So everything we're trying to do is really trying to capture this wave of investment in innovation. And when you think about it, I kind of come into a building like this and I see desk phones around and wall phones, and you have to imagine these are going to be the last hard phones or PBX devices that companies buy anymore when you look at the capabilities that WebRTC can provide. So our investment from a development perspective is really about the initial wave of leveraging and extending existing PBX and UC and contact center infrastructure. So some of the examples that Chad was showing up there earlier, like the Amazon example, is one where we've been involved in. So that's a very innovative use case of the technology. And certainly from a disruptive perspective, not every company can go off and build an Amazon Mayday type of solution, because it takes a fair amount of capital investment and people investment to make that happen. But that's ultimately where we're going to be going over time. So from a product development focus perspective, we have this thing in Oracle called the big red stack, or the technology stack. You see a little snippet over there. And it's really about putting the building blocks to invoke WebRTC capabilities or communication capabilities into every Oracle application that may exist, in terms of, and there's dozens, if not hundreds, of different Oracle applications. So that's one aspect of what we're doing. And there's another aspect of what we're doing from an infrastructure perspective. And when you look at WebRTC development, you have many choices out there in terms of, you have platform as a service options, you have open source technology options, and the type of customers that we serve, the tier one service providers, the Verizons, the AT&Ts, the Oranges of the world, and then the Fortune 500s, they might start with an open source or a platform as a service offering as a means of starting to work with the technology initially, but they often end up coming back to Oracle for some of their larger scale solutions. So we spent a lot of time thinking about kind of how do we complement the great security capabilities that exist in WebRTC, because one of the things that Chad just briefly touched on is that WebRTC, unlike its predecessors, has a lot of built-in security mechanisms in terms of the signaling is encrypted, the media is encrypted, and that's a huge advance forward from what the technology was beforehand. But there's still some challenges that we focus on, and then certainly from an interoperability perspective, a lot of the WebRTC use cases you see out there now are kind of what we consider to be walled garden approaches, where it's WebRTC and on both ends of the dialogue. And in the world that we live in, where there's still billions of dollars of investment in existing infrastructure that needs to be interconnected with. So we think about solving those problems as well. And then the reliability piece of it. I'm going to walk you through a simple example of something called session rehydration that kind of gets at the, how you can do very simple things to kind of improve the reliability. And the capabilities that we're going to talk about are built on something called the Oracle WebRTC Session Controller. So I work in the product development team. We have about 100 folks between the Boston area and California that work on this platform. And it's really a developer-friendly web platform for building communication features into applications. And a couple of the pictures that Chad showed earlier, he talked about the peer-to-peer model, and it's kind of evolving into one where you might have media elements in there. So, a big part of what we do is web to SIP or web to web flows, where you might need a conference, you might need to record, you might need to do other creative things with a media flow. So we have a media engine that's in the mix. The signaling mechanism, as you'll see when we get into the demonstration, we're actually using JSON over WebSockets. For those of you that have worked with WebRTC, realize there's no standardized signaling protocol, so it's really up to the implementer to choose what they want to use. We happen to be using JSON. It's married with a set of SDKs we have for Chrome, Firefox, Internet Explorer. And one of the things we've done with Internet Explorer to kind of tie in with what Chris was speaking of is that we actually have a flash fallback mode. So if your app happens to come up in Internet Explorer, we'll drop back to flash mode. If it comes up in one of the other browsers, we'll just use a standard WebRTC media stack. So that's what we're up to in that area. So I'm going to talk about something called enhancing session reliability with rehydration. And there was some work in the IETF a couple years ago that kind of launched this concept of rehydration. And what that, I'll explain what that is in a second. But when you think about using WebRTC in browsers or native applications that, we all multitask. I'm probably the worst offender when I'm on conference calls and video calls and you're banging away doing all sorts of different things. And that's great when you have your desk phone and that happens to be the communication device you're using. But if all of a sudden your browser or your native mobile application is that communication device, what's going to happen when you're starting to interrupt these sessions? So, that's one area we can run into problems, or certainly when you're transitioning from Wi-Fi to mobile or vice versa. And then, God forbid, server-side failures, those can happen as well. So if you don't properly address those challenges, it can really affect the user's RTC experience. And it really kind of gives WebRTC a bad name in terms of, I'm sure if any of you played around with WebRTC, sometimes it could be a little clunky in the early stages and you end up dropping back to your PSTN connection. And that's really not good to advance the technology. So what we're doing in our design is that we've taken some inspiration from one of the IETF straps it's RTC Web JSIP, and it kind of talks about in the event that the local application state gets reinitialized, either because the user's reloading the page or the application is refreshing one reason or another type of thing, you want to keep that existing session alive using a technique called rehydration. This wasn't some $10 marketing word that Oracle invented. You can thank the authors of this IETF draft for coming up with that one. But it really the goal is to resume the session with no interaction from the remote side other than standard signaling. And in the demonstration, you'll see what that's all about. So it really lets you kind of preserve the signaling state. And this is a big part of what we're doing on the back end side of our platform, but preserve the signaling state so it's there for the application to grab in a refresh mode. And another aspect of our inspiration in this area is that there's something called the Message Broker WebSocket Subprotocol, or MBWS, and it kind of lets you add some additional integrity checks from the WebSocket perspective so that when you want to add that extra degree of reliability to your WebRTC use case, you can leverage these tools. So I'm going to walk you through a short demo. I'm going to describe the demo first, and then I'll be bold enough to actually do the demo. So what we're going to do is that we'll set up a video call between two browser tabs. You'll see the session ID object in the JavaScript console. That's what we're using to kind of bring it back to life. And then I'll go into multitasking mode, and if you don't recognize that picture, that's Chad and his handsome young self up there. But he'll go to another website, and then we'll come back, and you'll see this session get resumed. So cross your fingers here. Okay, so I'm just going to bring up. I have a hosted one of our platforms that we're going to use, and I'm going to register a couple of endpoint applications here. So I'm just going to sign in here. This is going to be one at example.com, so we're going to connect him in there. So you can see the JavaScript activity on the left here. This is essentially an endpoint application registering onto the back-end network. And if you want to authenticate, you go off and do that. But you'll see that there's the session ID object. This is an important object that we're going to retain for purposes of session rehydration. So I'm going to do the same thing on the other side here. Thank you for Google for having a very reliable guest network. Of course, it doesn't solve my typing problems here. Okay, so now we have two endpoints, and I'm going to go off and just place a call to set up the video call between the two. All right, it's going to go off and ask for camera control here. You can see all the SDP goodness that ultimately will get replaced with ORTC that some people were knocking on. So, okay, let's send the call here. I called myself. Thank you for that. Someone's paying attention there. Okay. Of course, I managed to break my demo in the process here, so let me just re-register again here. All right, one more time here, and then we'll still have 6 minutes left before Chad gets the hook out here. So. Okay, so we got that endpoint connected. Got that endpoint connected, so now we will call the rec one this time. Okay. All right, so now we have our bidirectional video session. So this is the point where the session's up, everything is great. I'll clear out the console here. Well, everything was great. So much for me complimenting the Google network. So okay, so that's it. Anyway, so I will just go into multitasking mode at this point. So you can see that the session on the other end is kind of frozen. But if I happen to hit back in the browser, if I refresh the page, essentially it's going back to life. And you can see that essentially what it's doing, this was the called party. It's actually initiating a session back to the originating calling party, and we have our bidirectional video again. So anyways, it's not going to be as sexy, as interesting as some of the other demos you'll see tonight, but as a back-end guy, that's the best I can do. So,
I can vouch for Jim too. I just did a hackathon, used the Oracle, and it worked. It was a little sexier than that. I combined it with a Microsoft's Project Oxford computer vision APIs and connected it into the.
Yeah, we'll have to talk about that in a second.
Next time.
But anyway, so that if you happen to be working with Oracle's backend, and for any of you that are working with Oracle business applications, or as this platform starts to get adopted by the tier 1 service providers, and when you look at AT&T earlier this year, they opened up a developer portion of their network so people can write applications and leverage resources. I think if you've heard of a company called Twilio, that's a fairly disruptive company, and so the tier 1 service providers are all worried about them a little bit, so they're starting to open up their network in different ways. And when one of those tier 1 operators opens up their network, they tend to leverage platforms like Oracle provides as a means of doing it. Okay, so session rehydration, it's kind of a feature that Oracle has chose to embed into our client-server model, so that if you happen to be working with us, then it's a matter of your web app leveraging the hooks in our SDK to save the session ID, because that's really the secret sauce that allows the connection to get restored when you go into rehydration mode. And then, really what you want to do is when you're doing a reload, you want to check to see, do you have the session ID? If you do have the session ID, then you can restore the application to the point where you can bring the connection back. If you don't have it, then you end up bringing it back as kind of a new page, and the connection gets restarted. So if you've ever played around with Hangouts, which I kind of view as the gold standard, I played around with similar tests in terms of trying to interrupt the connections and heal flashes, and it appears to be, and maybe Chad, that Hangouts will actually reestablish the call from scratch type of thing, like when you break a Hangouts connection and bring it back type of thing. So there's different ways to achieve it. It's just that as WebRTC goes into prime time, you really have to kind of, from a use case perspective, these are the things that you need to think about. So it's one thing to do a hello world application in your lab and make some basic stuff work, but if you're asking people to throw away their desk phone or start using this as their primary collaboration tool, you really need to kind of address some of these challenges. So if you want to read a little bit more about what we're doing, I'll get to that in a second, but just kind of the last piece of it is that this is kind of an expanded version of something that Chad showed earlier in terms of, in the simplest WebRTC model, you basically have, a couple endpoints and a server in between. But when you start trying to address, the scalability in terms of, session hydration is a simple way to kind of improve session integrity. But the back-end elements in terms of, we spend a lot of time thinking about fault tolerance at the signaling level as well as the media level. So these media engines that we're talking about is that more often than not, you may have like centralized signaling resources, and then and then the media engines where you have your stun, turn, and ice, NAT to versal functions and conferencing capabilities and other types of media scaling capabilities. You might scale those independently type of thing. So, this is very important if you want to get the maximum scale. So when you start thinking about, the AT&Ts and the Verizons or even the Amazons of the world in terms of how they use the technology, this is why they tend to think about solving these types of problems from an architecture perspective. And if you want to read some more about our rehydration and how we've done it, just hit these URLs. We have a couple of examples in there in terms of code snippets, in terms of how you would do it. And then, as Chad has profited from, Oracle has been known to run hackathons occasionally leveraging WebRTC technology. We did one it was earlier this month, right? So TAD Hacks is telecom application developers and people from around the world write applications against Oracle's backend. And as Chad knows, they can win some money doing it.
Yeah,
so
it's good. It's not really that hard either. So,
so if you want to play around with the sandbox, one of our partners hosts the system, and I guess with that, I have 45 seconds left for some questions.
Yeah, do we have any questions for Jim?
The last guy between the break, I guess. So
Yeah.
it's,
Anybody? Well, obviously he'll be here during the break and afterwards. But
Stephen, please.
Can you talk about any of your customers? Can you talk about any of your customers' applications? What infrastructure they're replacing? What sort of SDN is below it? And
Yeah, so it's for us, we don't get too much involved in the underlying. Steve was asking about what kind of infrastructure that they're replacing, and one of the things I said in the beginning that it's often about extending what they have initially. So, for example, that when you're calling into American Airlines, for example, that you dial the 1-800 number and you punch through a bunch of IVR and eventually get to the right person and things like that. But in the new model, you're basically walking down the web page, and if you happen to be checking your mileage balance and say, hey, they didn't credit me for my last flight, for example, if all of a sudden you click on that, you basically get connected, right? You bypass the IVR. So there's the concept of visual IVR type of thing, going to bypass the IVR. So in that case, you're not necessarily replacing any back-end stuff yet, okay? But you're making it more efficient in the fact that when you finally get connected to the agent that you need to talk to, that person may only be able to spend 10 seconds with you versus having to listen to you for 60 seconds. So there's definitely a cost benefit associated with it. So ultimately, that stuff is going to get replaced. Like even if you look at the Amazon model type of thing. So Amazon being fairly disruptive, their application is WebRTC on an end-to-end basis type of thing. So they're not trying to throw it into some existing call center infrastructure and things like that. It really depends on the starting point of the organization that you're working with.